Okay, let's do problem number 3 on page 219, chapter 8. And here's the problem in the book here. It says a laser beam is directed at the moon 380,000 kilometers from the Earth. The beam diverges at an angle of theta of 1.4 times 10 to the negative 5 radians. It's a very, very narrow angle. What diameter spot will it make on the moon? And just to point out, one of the proofs that we have that humans actually walked on the moon, back in the late 60s, early 70s, is that the Apollo astronauts left reflectors on the surface of the moon, and you can shine a laser on it. It will reflect off that instrument still and come back to Earth. And by timing it, they did that so we could figure out exactly how far the moon is from the Earth. And and they still work. So, 50 years later almost. So, this coming summer it'll be 50 years since Apollo 11. Amazing. Anyway, let's do the problem. So here's the Earth. Here's the moon. I don't know. We'll kind of exaggerate the size of the moon, like we're closer to the moon than the Earth. The Earth is actually much bigger than the moon. But so we're sending from the surface of Earth. We got this beam of laser light, and it has an angle, very slight angle. This is what's given. Of the angle is 1.4 times 10 to the negative 5 radians. And we know the distance from here to here. That's our R. Our R is equal to 380,000 kilometers. Long ways. So we want to find we want to find the diameter of the spot that's illuminated. So we'll call that D. And it's pretty big spot. So let's solve it. Now here's really this spot, this illuminated spot, is kind of like an arc length. The diameter of the spot, if you have an angle like this, like theta, this kind of has an arc length right here, and I'm going to call that S. But we're going to say that S is equal to D. S is equal to the distance from here to here. And you can say that if the angle is very, very small, and this is obviously a really super small angle. So I have this basic equation, S is equal to R theta. The arc length is equal to the radius times the angle, as long as the angle is in radians. If you stick in an angle here like that's in degrees, it won't work. It has to be in radians. I mean, this is what defines a radian, is the arc length divided by the radius. So we're going to say that S equals D, our diameter of our spot, and that's going to be equal to 380,000 kilometers. And then we're going to multiply that by 1.4 times 10 to the negative 5 radians. And so when you do that, here's my calculator. 380,000 times 1.4 times 10 to the negative 5, and I get 5.32. But 5.32 what? Kilometers. Now, here's one thing to think about units. What is a radian? A radian is a length divided by a length. So it's really a dimensionless quantity. You can say 1.4, I'm going to change this, watch, instead of calling it radian, I'm going to say it's 1.4 times 10 to the negative 5 kilometers of arc length for every kilometer of our R. So this will cancel and you're left with kilometers. All right. So it's that simple. It's a pretty easy problem if you knew what to do. But it is, you have to, this is the basic equation you should know. And you should know that this has to be in radians, so make a note of that. Any questions? Okay, that is all. Oh, that is all.